Welcome to BKW Physics. I'm Mr. McConley. We're going to hook up some circuits today, specifically because we were just talking about ammeters and voltmeters. And so we're going to hook up the ammeters and voltmeters in a real circuit and see how it's all done. Now, if you notice down here where I'm pointing, cameraman, can you see that? This is your power supply. And on the power supply, there's various things that can be hooked up. You can use it like a normal outlet, which is an AC, alternating current outlet. These yellow knobs actually are AC also, but they're controllable AC. We're not going to use those. We're going to look over here at the black and the red knob, which are DC, or direct current, meaning the electricity comes out of one and comes back in the other. It's like a loop. It's like a car battery. It's like a battery in your stopwatch or your calculator or your phone. Direct current. So what I'm going to do is I'm going to hook up one wire with a banana plug into the red. This one's missing its banana plug, but that's alright. I can just pinch it behind here. I'll hook that one up to the black. Now, to see if things are hooked up right, I can do a basic test, which would be to just simply hook the two wires to a light bulb. You can see the light bulb comes on great. But that's a little bit too basic for what I'm trying to do. I want a little bit of a bigger circuit. So I'm going to send the electricity out of the red one up to the bulb. I'm going to go from that bulb to another bulb. I'm going to leave the second bulb and go to a switch. And I'm going to leave the switch, which is hooked back to the negative, so I have what's called a circuit. It's a complete loop of electricity. So now if I hook this up right and I close the switch, because when the switch is in the open position, it's off. When I close it, the light bulbs should come on. They are good. Seems like everything's working. I could make them a little brighter or a little dimmer. That doesn't matter for this particular instant. Now, the next thing I have is a voltmeter. And the voltmeter has different hookups. There's one that's always a negative, and then there's three others for the ones I have that have a 3, a 15, and a 300. What that represents is if you're on the 3, it means this thing can handle a maximum of 3 volts, or like 2 AA batteries. If I go to the 15, it can handle more. If I go to the 300, it can handle the most electricity. And these are for DC only. So I don't really know what I have for electricity, but I know it can't be more than 15, so I'm going to start with the 15. I put one of my wires on the negative black and one on the 15. Now, does it matter that I'm using 2 red wires, or does it matter that I switched colors as I went around the circuit? The answer is no. Makes no difference. The wires are just colored so it can help you keep track. In this case, it's not very confusing, so I just kind of mix and match wires, whichever I pulled out. So if I would like to know how much this light bulb is using, you will recall from the board, it's still written on the board, that you need to hook the voltmeter up in parallel, which means the circuit's running, and then I take these 2 wires and I put one on one side of the bulb. Now, you don't have to worry about getting shocked because DC, you're not, and it's very low voltage DC. I'm not going to get shocked from this, so I can touch it. It's fine. Now, I see that it's right about, I'm on the 15 volt scale, so I'm on the one that ends in 15, but I'm right about there, so I'm about 2.5 volts. So if I want to get a little bit more accurate, I can switch to the 3 volt scale, which actually now shows me I'm actually at about 2.6 volts. So this light bulb is using 2.6 volts. I touched each wire to each side of the bulb. I can see it's at 2.6 volts. Great. I wonder what the other light bulb is working or using. So I can hook it up to the other one. And you should pay attention to what I'm doing here, because in lab you'll actually be trying to do the same thing. This light bulb, surprisingly, must be a very different light bulb, because this light bulb's only using, on the 3 volt scale, we're only at between 1 and 2, or about at 1.4 and change. So this is only using 1.4, and this was using much more at 2.6. So those are not equal light bulbs. It'd be like using a 60 watt light bulb and a 100 watt bulb. They're 2 different bulbs. Good to know. Well, how much electricity is coming out of the actual source? So I could go down here and I could touch. This is kind of hard to do because they're all protected with plastic, but I think I can get it to touch. Oh, I pinned it. So I move over to the 15 volt scale, and I'm somewhere just under 5 volts. Okay, so that's how you test potential or voltage. The next thing I want to test quickly is with an ammeter. I want to test the flow of electrons. Now the flow of electrons comes out of here, goes around and back to there. So does it matter where I put this? No. It will be the same wherever I try it. So I'm going to put it in a convenient location, like right here. And I need to disconnect. I left everything on, but I disconnected this wire right here. And then I have to physically place the ammeter so it takes the place of where that wire was. So I put this here, and I put this, I guess I'll just hold it because I don't really have the right connector here. Oops, backwards. This one needs to be over here. Now I knew it was backwards because the needle moved the wrong way. And if the needle starts going left instead of right, it means I got to hook up the reverse. So I hook it here, and I'm just going to hold it with my fingers because I don't really have the right connector. And you can see that the light bulbs came back on, which is good, but you can also see that I'm actually reading a current. Now I'm on the 500 scale, and that's 500 milliamps. So I'm at about 200, so I'm at 200 milliamps, and 200 milliamps means 0.2 amps, because milli is 3 decimal places over. So I got about 0.2 amps flowing through this circuit, or 0.2 coulombs per second. Okay? That's it for today. Physics. Just hit this.